This is a quick video on transmissibility and sliding vectors. Let's pretend we have a rope that has a mass of 0 grams. So the mass is 0 grams, or the object is massless. So let's say we attach a rope right here, and this rope doesn't stretch or anything. So we attach a rope and pretend this is a straight line. And out here we have a guy pulling on it. So this guy is pulling on it with a force of 20 newtons. Pulling it that way. So the object feels that there is a force of 20 newtons being pulled right there. Now let's pretend that we are able to clamp the rope, clamp it right there. So we just stuck out a clamp and just screwed it into the object. Would it matter if we maybe cut this off, and now the force was actually being applied here? Would that be the equivalent of the 20 newtons being applied here? And the answer is yes. Now this is only for rigid bodies, bodies that do not deform. If the body deforms, then you cannot say it. Transmissibility is only for bodies that do not deform. And for our case, what we're doing right now, it's also for bodies that do not rotate. So the body cannot rotate. So that's why we have this little block here, preventing it from rotating around this pivot point. So let's say we again maybe clamp it right here. So let's say we clamp the rope right there. Is that the equivalent? And again, the answer is yes. That is the equivalent. The clamping the rope right here is the equivalent of having the 20 newtons right here. Now let's say we move it one more time to all the way to the edge. Is that the equivalent of pulling with 20 newtons right here versus here? These 2 points, to a rigid body that doesn't rotate, they are the equivalent. And we're not used to that in physics because we're used to things in physics moving. Since this is statics, things are staying static. They're not moving at all. So that's why it's a little bit difficult to understand this concept, because you're coming from physics where things are moving. Now things aren't moving. So transmissibility, another way of thinking about transmissibility is if, let's say we applied the force up here, right there, 20 newtons, instead of thinking of the force being applied right there, think of it as if there's a guy, there's a guy pulling a rope, and pretend this rope is straight, so pretend that there's a guy pulling that with 20 newtons. So anywhere on this rope, you can cut the line. And that is called the action line, or line of action. So when you think about this, think of it as a rope, and then the rope is actually called a line of action. So that is what transmissibility is. Just being able to think there's a rope and being able to clamp that rope anywhere in the direction of, or more importantly, in the direction and on the path of the force.